Okay, these are the notes over quadratic regression and modeling. It says the table shows the height h in feet of a wrench in feet of a wrench t seconds after it has been dropped from a building under construction. So we have time and we have height in feet. It's important that you guys understand time is your x variable because x is independent. You can't change time, you can't speed it up, you can't go backwards, whatever. The height of the wrench is dependent on the time since it was dropped. So height is your y values because it's dependent. So the steps on this problem are asking you to use a graphing calculator and explain why the data appear to fit a quadratic model. We're going to use a quadratic regression to find the quadratic model or the equation for the data. And then we're going to predict when the wrench hits the ground. So if you're in the classroom, you have a graphing calculator and you can follow all of these steps, but you're probably at home watching this video and you don't have your graphing calculator with you. So I am going to show you how to use Desmos. You can just Google Desmos graphing calculator or use the link that I posted in Schoology for you guys. So here we go. You're going to click this little plus button, add an item, and you're going to choose table. And our x values represent time. So we had 0, 1, 2, 3, and 4. And the y values were the height of the wrench at those specific times. So at 0 seconds, it was 400 feet in the air. After 1 second, let me see how tall it was. 1 second, it was 384. After 2 seconds, it was 336. After 3 seconds, it was 256 feet in the air. And after 4 seconds, it was 144 feet in the air. So now down here is number 2. You're just going to click in that little number 2 row. And now we're going to write our equation. So a quadratic equation is y equals, this is what it normally looks like. Y equals ax squared plus bx plus c. But we don't have an a, b, and c value right now. So that's what we need our calculator to do, is to come up, or our Desmos, to come up with those a, b, and c values. So you're going to start out by typing y and then the number 1, because you want these y values. This x1 and y1, that just means the x and y values from our first table, and we're only going to use one table at a time anyway. But that's just what Desmos does in case you have multiple tables at once. Then you're going to type the little tilde symbol that you use in Spanish class, or if you've ever typed anything in Spanish, it looks like this. And the way that you get that symbol, in math, it means y is regressed with. You hit the shift key and then the tilde symbol, it's usually in the upper left corner of your keyboard. So y1 regressed, and then we're going to type a x1, but then we have to square that. So shift 6 makes an exponent, and then you type the number 2 because we want it to be a 2. And then arrow to the right, and then we're going to say plus b x1, not just x. Remember, your x values and your y values have to have that little subscript, and then plus c. And you can tell right here underneath the equation, it says a equals negative 16, b equals 0, c equals 400. So y equals negative 16x squared plus 0x plus 400. And Desmos also goes ahead and graphs this quadratic for you. Now, let's go back. The time goes from 0 to 4, but we know our wrench doesn't stop in the air 144 feet off the ground. So this table is incomplete. All right. So we need to figure out some other values. Also, it doesn't make sense for our time to ever be negative. It doesn't make sense for our height to ever be negative. So let's change the window on Desmos. And all you need to do is press this little wrench, which is ironic. We're doing a problem with a wrench. So we do not need these negative values. We can go ahead and just start at 0. And 10 seconds seems like a decent amount of time for a wrench to hit the ground. We know the height is our y value, so I don't need that. We're going to go ahead and start at 0. And it's definitely higher than 6 feet in the air. We started out at 400. So you can start at 400. You can start at 400 and let's say 415 feet, whatever you'd like. So here is our parabola. And if I kind of click and drag it over, I can see it clearly. It starts way up here at 400, and then after 1 second, it's right here at 384. After 2 seconds, it's at a height of 336. After 3 seconds, it's at a height of, excuse me, 1, 2, yeah, 3 seconds, it's at 320, or 3 seconds is 256 feet in the air, and so on. So the reason that I know that these points create a quadratic model is because when I typed it into Desmos, we got this R squared statistic, and your graphing calculator will give it to you also. The closer it is to 1, the better the line of fit. So a perfect 1 means it's an exact fit, which doesn't really happen in the real world, but we're starting out with easier equations right now, okay? So that is our equation right there. And the question also asks, when does it hit the ground? Well, to hit the ground, you have to have a height of 0. So we want to find this x-intercept, or our 0. Now in your graphing calculator, you can find that on a graph. And here in Desmos, all you've got to do is kind of hold your cursor over that point and click, and it will pick that point. It will plot it. So 5, 0. This tells us after 5 seconds, the wrench is 0 feet in the air. And it also asks, can we tell how high in the air the wrench started? How tall was the building? Well, the wrench started on top of the building. So when time was 0, right before we dropped it, it was 400 feet high. So that's how tall the building was. Let's do one more practice problem. It says, the table shows the estimated profits Y in dollars for a concert when the charge is X dollars per ticket. Write a function to model the data. What is the charge per ticket that will maximize the profit? Our ticket price are the X values and our profit are the Y values. I guess this is like Beyonce or T Swift. I don't know. Somebody that charges a lot of money for their tickets. So let's go back to Desmos. And I'm going to click the triple bars up here and just start a new graph, or a new little graph here. So plus sign, add a table, and 2 was the first amount of tickets we sold. What else did we sell? 5, 8, 11, 14, 17. So 5, 8, 11, 14, 17. Now we're talking about price. 2 tickets, so we had 2,600, 6,500, 8,600, 2,600, 6,500, 8,600. Let's see, how much did 11 tickets cost? 89, 74, 41. So 89, 74, 4,100. All right, so there is our table of values. Again, X represents the number of tickets that were sold. Y represents the amount of money that was made for profit. So we're going to click in the second space, and we're just going to go Y1, regressed with A, X1, and then you press the Shift key and the number 6 at the same time, squared, arrow to the right, plus bx1 plus c. And we get another equation here. We get another graph. All right, so let's talk about what this problem is asking us. Well, first of all, our A value is -100, our B value is 2,000, and our C value is -1,000. Okay, so those are our values right there. So if you want to write this quadratic down on your note sheet, it's just y equals -100x squared plus 2,000x minus 1,000. So the questions that we are asked, it says write a function, did that, and what charge per ticket will maximize the profit. So if you look at the profit values right here, it starts to change. So it's 2,600, it's going up, and then it drops somewhere between 11 tickets sold and 14 tickets sold. So I'm not exactly sure what's going on right here. Maybe it went up somewhere between 8 and 14. So let's go to our calculator. Going to click on the wrench to change our window. We know we can't sell 0 tickets, so let's go from selling 1 ticket to selling, 20 tickets. That seems to be fine. Now, the cost or the price that was made, the profit, We can make $0. That's possible. And on the table, we made, what was that actual amount? The biggest amount we made was 8,900. So let's get a little bit bigger than that in case we made more somewhere in between. Let's go up to 10,000. Awesome. Perfect. So here we have this graph right here. Here's our quadratic. And again, on Desmos, if you kind of hover over where you think the maximum point is and you click, it will give you the maximum height right there. And so this right here says if you sell 10 tickets, you have a profit of $9,000. And that's our maximum value. When we sell 10 tickets, we sell a profit or we make a profit of $9,000. So that's just a way that we can use our data to come up with regression equations or a regression model and then predict outcomes based on that data. So go ahead and use Desmos to finish your homework assignment and have so much fun doing it.